Hi, this is Narayana from Narayana Techno. So today's our topic is writing the C program to print the multiplication of two matrices here. So before going to talking about multiplication of two matrices here, so in the previous video we given that addition of two matrices. So the addition of two matrices where we require number of rows and as well as columns of A and B matrices should be same, then only matrices addition is possible. And whereas in multiplication of matrices, the number of columns of first matrices should be equivalent to number of rows of the second matrices, then only matrices multiplication is possible here. So let's observe this one. We have this is A matrices here. In A matrices, 0th row 0th column is 2 and 0th row first column is 3 and first row 0th column is 4 and first row of first column is 5. Similarly, B matrices, 0th row of 0th column is 2 and 0th row of first column is 4 and 1 row of 0th column is 3, 1 row of 1 column is 5. Now here we require to be implement the multiplication of two matrices here. So how will we calculate multiplication of two matrices here? That is, if we let's observe this one here, two multiplication, that is 0th row of 0th column of A matrices should be multiplied with the 0th row of 0th column of B matrices plus 0th row of first column is nothing but here 3 multiplied with the 0th row of first row of 0th column. What is first row of 0th column is nothing but here 3. So 3 into 3 here. This is a first element in the same matrices here. Similarly, 0th row of 0th column of A matrices, that is nothing but 2 multiplied with the 0th row of first column. What is 0th row of first column is 4 plus 0th row of first column should be multiplied with, that is 3 multiplied with 5. This is a second element in the same matrices here. Similarly, first row of 0th column, what is first row of 0th column of A matrices is called 4 multiplied with the 0th row of 0th column of B matrices is nothing but 2 plus first row of first column is nothing but 5 multiplied with the first row of first column, that is first row of 0th column. What is first row of 0th column is here. This is the next element of C matrices. Similarly, B of 1 of 0. What is 1 of 0 is nothing but 4 multiplied with B of 0th row of first column. What is 0th row of first column is 4 plus again A of 1 of 1 nothing but 5 multiplied with B of 1 of 1. What is B of 1 of 1 is 5. This is the next element. So that is nothing but here 2 is the first 0th row of A matrices of 0th row is multiplied with the B matrices of 0th columns. What is 0th columns are called 2 and as well as 3 here. So 2 and 3. Similarly, A of 0th row of 0th row is again is multiplying with the B of first columns, nothing but 4 and 5. Similarly, next time this is first row is multiplied with the 0th columns of B matrices. Again, first row is multiplied with the first columns of B matrices here. So it's nothing but here. If let's observe this one here. What is this elements we are getting now? 2 into 2 is nothing but 4. 4 plus 9. 4 plus 9 is, that is called as 13 here. That is 4 plus 9 is 13. Here 2 into 4, 8. 8 plus 15. 8 plus 15. So 2 into 4 is nothing but 8 plus 15 here. So what is 23 here? 23. Then 4 into 2, 8. 8 plus 15. 8 plus 15 is again 23. Again here 4 into 4. 4 into 4 is 16. 16 plus 25 is nothing but, what is 16 plus 25 is nothing but 41 here. So this is a elements here. So these are the elements 13, 23 and as well as 23 and as well as 14 here. This is called as C matrices elements here. These are called C matrices elements here. So after multiplication of AB, we are getting like this here. C matrices is like this here. So this is the way we should be able to implement the multiplication of two matrices of A and as well as B here. So that is, if you observe this one here, here this is in the A matrices the columns are changing, and in A matrices the row is multiplied with B matrices of columns, and is nothing but here what is going to happening here. In A matrices the columns are changing and B matrices rows are changing here. Okay, nothing but here. If we let's observe this program, how we can implement this example is hash include std avoided dash unlock.h into pointer to pointer A, B and as well as C, R1, C1, R2, C2, I, comma J. Printf enter the number of rows and of columns of first matrices. Scanf percentage percentage R1 and C1. Printf enter the number of rows and columns of second matrices. That is nothing but scanf percentage R2 and C2. What is our condition is if number of columns of first matrices should be equivalent to number of rows of second matrices, then only multiplication is possible. If C1 is equivalent to R2, then we are writing this example allocation of dynamic memory for A, B and C of rows here. A number of rows are R1 and B number of rows are R2 and C is number of rows are coalesce. So this is number of rows here, that is R1 rows and C2 columns of C matrices here. So how will allocate dynamic memory for columns here? For I equivalent 0, I less than R1, I plus plus A of I equivalent to into pointer malloc C1 multiplication size of integer and C of I equivalent to into pointer malloc C2 multiplication size of integer. Then for I equivalent 0, I less than R2, I plus plus B of I equivalent to into pointer malloc C2 multiplication size of integer. Printf into the first matrices elements. For I equivalent 0, I less than R1, J equivalent 0, J less than C1, then scanf percentage A of I plus J. This is accepting A matrices. And then printf into the second matrix, nothing but B matrices. For I equivalent 0, I less than R2, J equivalent 0, J less than C2, scanf percentage B of I plus J. This is reading the second matrices elements. After accepting A and B matrices, then we are using like this. For I equivalent 0, I less than R1, I plus plus. For J equivalent to 0, J less than C2, J plus plus. So the C resultant matrices is R1 rows of C2 columns here. Now if you let's observe this one here. For again pointer C of I plus J equivalent to 0. First time we are initializing. So this loop is we are using another third loop here, that is called as K loop. This K loop is number of column changes in the A matrices and number of rows change in the B matrices here. So if you let's observe in the above explanation what we given the values here. So if you let's observe this one here, that is rows, these are called as 2 column and this is third column. Here 2 0th row and this is first row. Here the columns are changing, here the rows are changing. Nothing but in A matrices the columns are changing and B matrices rows are changing. That is a loop we are going to implementing. That is to be change the columns in A matrices or change the rows in the B matrices here. That is we are going to implementing the K loop for K equivalent 0, K less than either C1 or R2. That is called as the number of rows. Nothing but what is the rows in the B matrices are nothing but here R2 here. K plus plus here. Pointer C of I plus J equivalent to pointer C of I plus J. Pointer E of I K is multiplied with the pointer B of K plus J here. So that is nothing but pointer of E of I plus K is multiplied with the pointer of B of K plus J. What is K here? That is a number of columns changes in A matrices and number of row changes in B matrices here. So if you let's observe this one, when I 0 and J 0 and K 0. What is happening? C of 0 0 equivalent to C of 0 0 plus C of 0 0 K. What is K? E of 0 0 plus B of 0 0. What is E of 0 0? This is called as E of 0 0. What is E of 0 0 is nothing but here 2 and B of 0 0 is nothing but 2. Nothing but 2 into 2, nothing but 4. After this one here, then what is going to happening here? Again K plus plus. What is K plus plus is nothing but here 1 here. Then again already C of I J is nothing but 4 plus E of I. What is I 0 plus K. What is K is nothing but 1. E of 0 1 multiplied with B of 1 0. So E of 0 1. What is E of 0 1 is nothing but what is E of 0 1 is E of 0 1 is 3 and B of 1 0 is nothing but 3 into 3. This is called 2 into 2 plus 3 into 3, that is 9. 9 plus 4 is 13. That is a value in the C matrices. It's going to just storing that is in C matrices like this. Next time K plus plus. What is K plus plus becomes a 2. Condition false. After condition false, it will come out from K loop. After come out from K loop, then again J plus plus. What is J plus plus is nothing but here 1 here. So again J plus plus 1 is nothing but pointer C of I J, nothing but pointer C of 0 1 equivalent to 0. Again K will be 0. So C of 0 1. What is C of 0 1 equivalent to? C of 0 1 is already 0 plus E of I k, nothing but E of 0 0. What is E of 0 0 is nothing but here. What is I value here? E of I k. Nothing but I is 0 and k is 0. Then B of 0 0, B of k, nothing but B of 0. Okay, what is J 1? So if you let's observe this one. What is the value here? E of 0 0 is multiplied with the B of 0 1. What is 0 1 is 4. So what is E of ik? Ik is nothing but here 4 here. So this is nothing but here 2. And E of ik, nothing but E of I is 0 0. E of 0 0 of k, k nothing but 1. So 0 0 0 0. That is called as, what is the value is going to changing now? It is called 2 into 2 into 4 plus 3 into 5. 2 into 4 plus 3 into 5. This is E of ik. What is ik? Nothing but ij. E of ij is nothing but I is 0 and j is 1. Nothing but that is E of ij. This is ij. This is j. J is 1. And B of kj. What is k is nothing but here 1. So here 1 is going to changing. Again it's a kj. J is nothing but here 1 1 1. So B of kj nothing but 1 1. So that is what is a value here. This is called. So E of I. What is I j? Nothing but here I k. E of I k. What is I k? E of I k multiplication B of k j. 0 0 is multiplied with k 0 1 0 1. Nothing but what is the value here? 0 0 0 1 0 0. What is 0 0? 2. 0 0 is 2 is multiplied with 0 1. What is 0 1 is 4. 2 into 4 here. Next time k plus plus. What is k plus plus? Is going to incrementing E of ik, nothing but 0 1. Nothing but we again multiplied with B of kj. What is B of k is nothing but here 1 1. Nothing but 3 into 5. 2 into 4 plus 3 into 5. What is the value here? 8. 8 plus 15 is nothing but here 23. That is the value is printing like this here. Next time again j plus plus. What is j plus plus? Ik plus plus condition for j plus plus condition for j. Then after I plus plus. What is I plus plus is 1. That means one row is completed. Again j will be 0. So this is C of 1 0 equivalent to 0. K will be 0. Again, so pointer C of I plus j equivalent to pointer C of I plus j plus pointer E of I k plus multiplication pointer B of k j here. So here if you let's observe this one here. What is I j? I is 1 and j is 0. K is also 0 here. What is I is 1? Nothing but E of 1, this is 4 multiplied by E of 0 j. Nothing but 4 into 2. Then next time k plus plus increments that. So E of ik is nothing but 5 and then B of kj. Kj is nothing but 3. So nothing but 4 into 2 multiplied with 5 into 3. And then j plus plus. What is j plus plus? E of ik. Again 4 into 4. So 4 into 4. And 4 into 5 into 5 here. So like this you will get the multiplication of these two values here. So if you let's observe this one here. Next time j plus plus here k will be 0. E of C of pointer C of I plus j equivalent to pointer C of I j plus pointer E of I k multiplication pointer B of k j here. Like this you will get the values to be multiplied to be stored in same matrices here. So if you let's remember this one here. So in multiplication of two matrices, so only one thing to be remember, the row of A matrices is going to multiplying with the columns of B matrices. For this purpose we taken one additional loop is called as K here. So that is K loop is going to changing the rows of that is rows of in columns of in A matrices and rows in B matrices here. For this purpose only we taken this K loop here. And finally you will get resultant matrices is R1 rows of C2 columns here. So then after this one printf multiplication of two matrices. So matrices multiplication is for I equivalent 0, I less than R1, I plus plus, j equivalent 0, j less than C2, j plus plus, printf percentage d slash d pointer C of I plus j here. Otherwise pointer to pointer C plus I plus j here. So then it's going to pass into new line and then close this j loop here and close this if condition. then if R1 is C1 is equivalent to R2, if the condition is false, the control is positive. Else, here we are going to using to say that printf multiplication is not possible here. So in our program, it is going to printing the multiplication of two matrices when the number of columns of A matrices is equivalent to number of rows of B matrices, then only multiplication is possible. Otherwise, multiplication is not possible here. So users, you may be understand the difference between the matrices addition and as well as matrices multiplication here. So in case if you want to print the multiplication of matrices subtraction, that you can write in the addition matrices, you just try to change with the minus here. So you please try to write some of the examples using this two-dimensional mechanism. Write a C program to print the subtraction of two matrices. That is one example. And next example, you just try to write a C program to accept any matrices and print the transpose of the matrices. And another example, you write a C program to accept any matrices and print the matrices is unit matrices or not. And one more example also, you just try to implement, write a C program to print the sum of the diagonal elements mechanism. And write another example also, write a C program so to print the transpose of the inverse matrices of the matrices here, that is inverse matrices here. So you just try to write these examples also using the matrices mechanism using the two-dimensional arrays, so that you will become a good programmer in two-dimensional arrays programming using the dynamic mechanism here. So users, if you like this video, please like and share, and for more updated videos, please subscribe our channel. Thank you one and all.